Not able to write you. So it's here. Yes. Good morning, everyone. Um, we are going to repeat the lecture which we had on Wednesday when there was some connectivity issue leading to poor audio and visual delivery of the lecture. So let me also give an important information concerning the revision week. The revision week for all students starts uh, next week, Monday to Friday. And we are going to use this opportunity, maximize this opportunity to revisit some of the areas, especially in the electrochemistry. In electrochemistry, we are going to use this opportunity to revisit areas where you may be finding difficult. So I'll implore every one of you to be ready for this tutorial class. In addition, radioactivity, which is the remaining part of the lecture for Chemistry 101 for this semester. The note will be available today, and we are also going to uh, take care of this next week. Tentatively, the time for the lecture will be Thursday period and Friday period. And it will be physical because we want to take this as opportunity for us to interact. You can uh, come to the board, provide solution. We provide the solution together so that it can be more interactive. So, and that is what we plan. We are going to use the revision week to do that. So, radioactivity will be treated on Thursday, Friday, together with providing solutions with a number of questions in electrochemistry. I want to get a feedback. I want to I want to get a feedback. Try to see whether you can hear me clearly so that I'm not going to be speaking to the air. So I want to know whether you can hear and see the slide clearly. Okay. Yes. Thursday and Friday will be physical. I believe that is all right. Is that all right? Okay, you can hear me. The slide is not showing yet. Someone is saying the slide is not showing yet. So, can you see the Yes. Can you see the slide now? Can you see this? Okay, you can see it now. And you can also hear me clearly. All right, beautiful. So, as I was saying, we are going to have um, a revision next week. So, I'm going to communicate to you about the time. The time will be our regular time. You have the original timetable for physical classes. So we are going to follow the timetable, okay? And the groups will also be followed. So if you belong to group A, make sure you come uh, when it is the turn of your group, okay? I don't want the venue to be overcrowded. Each group will be attended to, all right? Let me give you first attendance code. M for magnesium, M for magnesium, 8 V M 7. M 8 V M 7. All right. So we quickly discuss cells and battery. Like we said on Wednesday, uh, cell is a single unit of device that converts chemical energy into electrical energy. Okay, and it is different from a battery because battery is a collection of cells, multiple cells that convert chemical energy into electrical energy. Cell is a single unit. But when you have combination of multiple cells, you have a battery. And there is another important characteristic of a battery. A battery is often rechargeable. So because of that, they are often referred to as secondary cells because they can recharge after discharging electrical energy. Why are they able to do this? The electron reactions in batteries are reversible. Just as a cell has two electrodes, you have multiple cells in a battery, okay? And you have electrode reactions. You know which reaction is your anode, sorry, which electrode is your anode, which electrode is your cathode. On each of these electrodes, you have reactions occurring, and these reactions are reversible in batteries. So because they are reversible, it means when they are discharging the energy, okay, that reaction is in the forward direction. When they are recharging, the reaction is going back. Okay. So we are going to see an example of this as we move on. So this is why uh, batteries are referred to as storage devices. We have talked about Daniel cell. Okay, There are other cells that we need to mention, even though we are not going to talk about them in depth. They are also like Daniel cell, but with different operational principles. An example of such cells is the standard Western cell. Okay, we also have the Leclanché cell. The Leclanché cell is in two types. We have the wet Leclanché cell and we have the dry Leclanché cell. All right. So both the dry and wet Leclanché cell, okay, especially for the ammonium chloride electrolyte Leclanché cell, they have the same type of reactions occurring in them. So I want you to note that the wet Leclanché cell is just one single individual or one single type of cell. The dry Leclanché cells also have different types. The dry Leclanché cells has different types. You have the wet Leclanché cell and you have the dry Leclanché cell. In the dry Leclanché cell, you also have different types of dry Leclanché cells, depending on the component of the dry Leclanché cell, depending on the component with which the dry Leclanché cell is built. For example, let us talk about the dry Leclanché cell, which has ammonium chloride as the electrolyte and zinc as the anode. Okay, zinc as the anode. We also have another dry Leclanché cell which has alkaline material. For example, KOH, potassium hydroxide or sodium hydroxide as its electrolyte, and it also has zinc electrode as its anode. Okay, you realize that we are not mentioning the cathode because the cathode material is the same for the Leclanché cell, and that is why these different types of dry Leclanché cells are also regarded as Leclanché cell. The cathode material that you use in the wet Leclanché cell is the same cathode material that you use in the dry Leclanché cell. What is this material? We are going to talk about it as we move on. So in essence, we are saying that the cathode material is uniform, okay, in the dry Leclanché cell. However, the electrolyte type, okay, and the type of the anode in the dry Leclanché cell can make a difference, in how the Leclanché cell will operate in terms of efficiency. So we are giving some examples. Uses ammonium chloride is the electrolyte in a dry Leclanché cell. It's a type of dry Leclanché cell with zinc as the anode. Another one is KOH or sodium hydroxide as electrolyte with zinc as its anode. Another type of dry Leclanché cell is using ammonium chloride or KOH as its electrolyte. However, the anode is not zinc material, but magnesium material. So in all, depending on how you put this component together, you are going to produce different type of plant dry cell. Okay, now let us look at the component using uh, wet Leclanché cell as an example to start with. The wet Leclanché cell is no longer in use these days, but it was used in the past to operate electric bells and telegrams. And the diagram before you is showing the component of this cell. This cell can produce between 1.6 volts to 1.4 volts. So the maximum voltage that it can produce is 1.6 and it can fall to about 1.4 volts due to polarization. When we say polarization, it is the development of insulating barrier between the anode and the electrolyte during production of current. Okay, that is when current is withdrawn, you produce some materials. For instance, you can produce ammonia. Ammonia will adhere onto the surface of the anode or the cathode, thereby causing uh, prevention, inhibiting the flow of current and reducing the efficiency of the cell. Okay, what are the components of a wet Leclanché cell? You have everything put in a glass jar. You have the electrolyte solution. Ammonium chloride is the electrolyte in a wet Leclanché cell, and it is prepared using water, aqueous ammonium chloride. You also have the carbon plate, which is the inert material on which the cathode material is placed. The inert material on which the cathode material is placed. Carbon plate is the inert material, and around it you have the powdered carbon and manganese 4 oxide. Powder carbon and manganese 4 oxide is actually the cathode material, okay, but it is placed on a carbon plate. Around this cathode material is a porous pot, okay, that controls the access of the solution, the rate at which the solution reaches, the electrolyte solution reaches the cathode, okay, and then you have the zinc rod, which is your anode, okay. You have the zinc rod, which is your anode. Okay, so the manganese 4 oxide functions as the cathode on an inert carbon electrode. It serves to oxidize any hydrogen present to water. So when you have the cell, the hydrogen gas that may be present will be oxidized to water. Why is this important? Because hydrogen gas could act as one of those depolarizer, okay, that can cause, I mean, one of those polarization material that can cause polarization. That is, that can cause a barrier in production of current. Okay, that can cause a barrier in the production of current. The pot and a zinc rod. So that means we can say that manganese 4 oxide act as a depolarizer. Okay, preventing the cell from being, polarized, preventing the cell from being disturbed by some materials which can cause barrier uh, in production of current. So the pot and a zinc rod, which is the negative electrode, are placed inside a glass jar containing a solution of ammonium chloride. We have said that already. So the dry cell, we have the picture in the next slide. This dry Leclanché cell that uses ammonium chloride gel is still in use. For some of you who know the red tiger battery, the red tiger battery is an example of the dry Leclanché cell. And the makeup of it is similar to that of the wet Leclanché cell, except that the electrolyte is gel. The electrolyte in this one is gelled. It is not a solution like in the wet Leclanché cell. Okay, so the dry Leclanché cell is made up of the same component as the wet Leclanché cell, except that ammonium chloride electrolytes are gelled by the addition of starch and flour instead of aqueous ammonium chloride solution to prevent spillage. Okay, so to make it more compact and portable, you can carry it everywhere. Okay, that is why the electrolyte is made in form of a gel instead of, solution, which can spill up and be very difficult to move around. So the dry cell is used, the dry Leclanché cell, with ammonium chloride as electrolyte is used in flashlights, portable radios, timers, televisions. You know where you use this tiger battery, okay? And the anode reaction that is occurring, whether it is a wet plant cell that uses ammonium chloride solution as electrolyte, or a dry plant cell that uses ammonium chloride, but not a solution, gel, okay, as its electrolyte. The same electro reactions occur. So on the anode, you have the zinc rod dis dissolving in the electrolyte to produce zinc 2 plus and 2 electrons. Okay, that is where the electrochemical reaction starts from. Production of the two electron, and I have told you once electron is produced, current will flow in the opposite direction. Electron moving in one direction, current flows in the opposite direction. Okay, the manganese 4 oxide, which is placed on on the carbon plate, inert carbon plate, okay, react with water, water vapor around, hydrogen which may be present will be oxidized to water, and this water can also be a precursor for an additional reaction. Okay, plus the two electrons released, you know, two electrons will be absorbed on the surface of the cathode, released. Okay, in addition with the manganese 4 oxide, we cause a reduction in manganese 4 oxide to manganese 3 oxide, as you see on the screen, with production of hydroxide ion. You produce hydroxide ion. What is the source of this hydroxide ion? Okay, what is the source of this hydroxide ion? That we will see in the next slide. And when you add these two electrode reactions together, when you add these two electrode reactions together, you have a complete or full cell reaction, which is written below. Okay, now you know how you determine the EMF of the cell. The EMF of the cell is E, the reduction potential of the cathode, plus the reduction potential of, minus reduction potential of the anode. The EMF of the cell equals the reduction potential of the cathode minus the reduction potential of the anode. The reduction potential of the reaction occurring on the anode is actually minus 0.76 volts. We wrote plus 0.76 volts because we have presented the equation as an oxidation. I want you to note that because we have presented the equation as an oxidation. That is why this is written as plus 0.76 volts. If you recall, the reduction potential, which is zinc 2 plus 2 electron giving zinc, is minus 0.76. So that reaction is occurring on the anode, okay? And the reduction potential for the reaction on the cathode is given as 0.74 volts, okay? The E cell, as you know, is going to be 0.74 minus 0.76, which will eventually give you 1.5 volt. And that is the EMF, that the maximum EMF that the cell can produce. If you look at the Tiger battery very well, it will be written there that the voltage that the cell can produce is 1.5 volt. You see, I've been interchangeably using the word battery and cell for the Tiger. The Tiger uh, battery, we usually call it battery, that we all know is actually a cell. Okay, it is not a battery because it contains just one single unit cell. Okay, just one single unit cell with two electrodes and electrolyte. Okay, but for batteries usually contain multiple cells. All right, which on their own separately can produce a certain amount of energy, a certain amount of voltage, and cumulatively, when you put these uh, voltage together, you have the total amount of voltage that the battery can produce. You will see by the time we get to the lead acid battery, and you see exactly what we are talking about. So now, the hydroxide ion, okay, the hydroxide ion product. I want you to note that this process, contain water vapor, right? Which will be the source of your hydroxide ion. Okay, you have hydroxide ion. That is if you are talking about the dry Leclanché cell, okay, water vapor. But if you are talking about the wet Leclanché cell, you know quite well that the ammonium chloride solution is produced. with the by dissolving ammonium chloride salt in water. So the water used in preparing the ammonium chloride solution is is going to be is going to be the source of the hydroxide ion. All right. So the hydroxide ion from this from this equation, from this electrode reaction, you see that uh, it has reacted with the zinc 2 plus in the full electrode reaction. You can see it that this led to the formation of zinc hydroxide in the full electrode reaction. Okay, so the excess hydroxide ions are mopped up by ammonium ions from ammonium chloride. Okay, now the ammonium chloride, which is the main electrolyte, okay, can also react with the excess, some of the hydroxide ions that are left, leading to the formation of ammonia, okay, according to the equation on the board, I mean on the screen, leading to the formation of ammonia according to the equation on the screen. Ammonia and water will be produced. And I also want you to have it at the back of your mind that what is the driving force for the dissolution of the zinc electrode? What is the driving force? Okay, ammonium chloride has this tendency of hydrolyzing. It can undergo hydrolysis to produce H plus eventually, which will make the environment acidic. Okay, because the environment is acidic, this will increase the rate of dissolution of the anode, which is the zinc rod. Okay, so zinc rod will dissolve at a faster rate than if the environment is alkaline. So by the time we get to the alkaline type of Leclanché cell, we will understand better what I'm talking about. Okay, so zinc, okay, dissolves because the environment is acidic. As a result of the formation of hydrogen ion, hydrolysis is the reaction between ammonium ion and water. Okay, water giving you ammonium hydroxide and H plus. H plus that will be produced there is making the environment acidic. So let us move on. Ammonium hydroxide reacting with hydroxide, ammonium ion reacting with hydroxide ion to mop up the excess hydroxide ion, leading to the formation of ammonia and water. The ammonia gas formed can adhere to the cathode and cause disruption of the current. So this ammonia gas is not good for the efficiency, okay, for the efficiency of the cell. The cell efficiency will be reduced when ammonia gas is produced. Okay, the more ammonia gas that you have in the cell, the more the efficiency of the cell becomes decreased. Okay, so the ammonia gas form can adhere to the cathode and cause disruption of the current. Okay, ammonia is one example of a material that can cause polarization. Okay, now, this is prevented. What is now done is to prevent the formation of ammonia, or is to mop up the ammonia that is being formed. Is is what was done to mop up the ammonia that is being formed, okay, is the reaction between ammonia and the zinc ion. Okay, the zinc ion in the solution reacts with ammonia to produce uh, a crystal, a white crystal. Okay, for some of us who are very conversant with the use of tiger battery, you find out that after a prolonged use of tiger battery, you notice some white flakes, okay, at the negative terminal of the cell. So that white flake is the crystal that we are talking about, and it is made of the zinc diamine complex. Okay, the zinc diamine complex. So the cell get deteriorated over time due to the continuous leakage of ammonia and the production of the white crystal at the anode. So after prolonged use, and the cell has produced so much of ammonia and the zinc diamine complex, that is when you see that the cell can no longer function properly. The cell can no longer produce as much voltage as is needed or required. So let us now move to the other Leclerc cell. But before we do that, I would like to give you the second code. The second attendance code. Okay, now are you not seeing the slide again? You are not seeing the slide. Okay, you can see it now. All right, you were not seeing it uh, earlier. All right. Okay, that is noted. Sorry about that. These are some of the technical glitches that we experience. So the second attendance code, you have 7, figure 7, TSUT, figure 7, TSUT, figure 7, figure 7, TSUT. Don't worry, it will be enlarged. Figure 7, TSUT. Thank you, Urbanity. All right, that is the attendance code. So the other types of dry Leclanché cells that are available commercially and that can give improved performance are the following. The alkaline dry cell is a superior form of Leclanché dry cell and contains KOH or sodium hydroxide instead of ammonium chloride as the electrolyte. Okay, why is this superior to the one made of ammonium chloride? This is why. The anodic why is because in alkaline medium, the zinc rod does not dissolve as much as it will dissolve in an acidic medium. So for this reason, so the advantage of the alkaline dry cell is that zinc does not dissolve readily in alkaline as it would in acidic medium. And so the cell maintains its voltage when current is drawn. The anodic reaction in an alkaline Leclanché cell, dry cell, occur in two steps, leading to the formation of zinc hydroxide. On the anode, you have the formation of zinc 2 ion, zinc 2 plus 2 electrons. Okay? And the hydroxide ion reacts with this zinc 2 plus to produce zinc hydroxide. All right? That is in one phase. So the zinc electrode, okay, can also react with the hydroxide ion to give zinc hydroxide solid. Okay, on the cathode, you have the same reaction on the cathode, and that is what I said at the beginning, that the cathode uh, material is the same for wet Leclanché cell that uses ammonium chloride solution as its electrolyte. The cathode material is also the same uh, for dry Leclanché cell that uses ammonium chloride solid or paste, because it's a gel, not entirely solid paste. Okay, ammonium chloride gel as its electrolyte. The cathode material is also the same for the alkaline Leclanché dry cell. Okay, for the alkaline Leclanché dry cell. Okay, that uses KOH or sodium hydroxide as its electrolyte. So if you look at the cathode reaction, you see that it's not different from the one of the ammonium chloride type, and the only difference is that the electrolyte in this case is not ammonium chloride. Okay, so the full cell reaction is obtained by adding the cathode reaction and the anode reaction together, and you obtain the full cell reaction as you see on the screen. So the advantage, as I said earlier, of the alkaline dry cell is that zinc does not dissolve readily in alkaline as it cooled in acidic medium, and so the cell maintains its voltage when current is withdrawn from it. So the voltage of the cell is not dropping, okay, because the material is not degrading. The material with which the cell was made is not degrading, unlike in the uh, ammonium chloride Leclanché cell, which will provide an acidic medium for the reaction to occur. But in the alkaline medium, the zinc rod does not readily dissolve. It is not as if it's not going to dissolve, but the rate of dissolution is not as fast as when it is in the acidic medium. So the magnesium dry cell is another type. You know, we have talked about the alkaline dry cell where the cathode material is not different, and the anode material is also not different. The anode material has always been zinc rod, okay, and the cathode material has always been powder, carbon, and manganese 4 oxide. Okay, but this time around, we want to talk about a dry Leclanché cell that uses, instead of zinc rod, uses magnesium as its anode. Okay, magnesium as its anode, and it can either use KOH or sodium hydroxide or even ammonium chloride as its electrolyte. Okay, so the only difference will be the anode. Instead of using zinc, it uses magnesium metal. Okay, and the cathode material is still the same, powdered carbon and manganese 4 oxide on carbon plate material. That is still the same cathode material that we have discussed, that we used in the other type uh, of Leclanché cells that we have discussed. So the reduction potential, the reduction potential for magnesium ion slash magnesium electrode is minus 2.37 volts. That is high compared to minus 0.76 from the zinc 2 ion slash zinc. Okay, the reduction potential for zinc 2 ion slash zinc is minus 0.76 volt, while for magnesium 2 ion slash magnesium is minus 2.37 volt. Okay, so if we assume that the cathode material is the same, which is powdered carbon and manganese 4 oxide, we know the reaction that will occur, okay, on the cathode. Okay, that reaction has a reduction potential of 0.74. Okay, so that means 0.74 minus 2.37 will be the maximum voltage that a cell made with magnesium material as the anode, we produce magnesium material as the anode, we produce 0.74 plus 2.37 volts, while that made with zinc we produce 1.5 volts. Okay, so that is why the magnesium dry cell is preferred compared to the zinc uh, dry cell. So this implies that the magnesium dry cell will generate a higher voltage than 1.5 volts generated by the zinc dry cell. Now let us talk about the secondary batteries or storage batteries. So the battery, as defined, is a device that contains multiple cells. Okay, it's a collection of multiple cells. Okay, so different from a cell. And these batteries, their electro reactions are reversible. So the galvanic secondary cells, which are called batteries, secondary, okay, is different from primary. Secondary cells are batteries, while cells are primary. Okay, batteries are secondary, cells are primary. So the galvanic secondary cells are those in which the electro reactions are nearly reversible. The lead acid battery, let me give you the last attendance code. The last attendance code is figure 3, figure 8, JF5. I've been changing the slide. Let me just refresh. No, no, make it better. I made it bigger. This slide will refresh so that I just came. Can I use 38JF5? That is it. Okay, what about the slide now? Yes, you are going to get the slides. I'm going to send the slides to you through your course reps, through your course reps. So you should be seeing the secondary storage batteries now on the screen. On the screen, you should be seeing the secondary storage batteries. Okay, don't worry, we are going to have a revision lecture next week. Okay, and tentatively the time is Thursday, using the time that we have on our original physical classes, and the venue is 1,000 seater. Okay, where we have always used for our physical lecture. So we use the venue, we use the time that we have originally in our timetable. Thursday and Friday are the 2 days that we have picked tentatively. If there is going to be any change, I'm going to communicate to you as appropriate and as at when due. So you still cannot see anything. Okay, okay, better. All right. So let us quickly conclude this and then we meet next week, but physically to treat questions on electrochemistry and to also discuss radioactivity. So this is the lead acid battery. It consists of 6 cells. Each can produce up to 2 volts. Because it has 6 cells, the total amount of voltage that the cell can produce is 12 volts. So the 12-volt battery is used mainly in automobiles. So the cathode of each cell is composed of lead 4 oxide, while the anode is lead. The anode that will produce the electron is lead, okay, while the cathode that will take up the electron is lead 4 oxide. Both electrodes are immersed in 1:3 volume to volume concentrated tetraoxosulfate 6 acid water solution. Okay, then we can ask you, why is the uh, electrolyte not prepare as 3:1 concentrated tetrasulfate 6 acid to water? Why is it 1:3? Okay, this is because you enhance ionic mobility when the electrolyte is more dilute. Okay, ionic mobility is enhanced, and you know it is the ions that carry charges. Okay, it is the ions that carry charges. So that is why it has to be 1:3. Okay, volume to volume concentrated tetraoxosulfate 6 acid and water. So the electrode and cell reactions as given on the screen. Okay, with the anode reaction giving us lead solid because the anode is lead metal. Okay, in the presence of sulfate ions, produce lead sulfate and two electrons. The charges are balanced on both sides. You can see you have two sulfate, two ion, and then you have plus two electrons on the other side. The charges are balanced as well as the masses. The cathode, of course, you see the reaction occurring on the cathode, and you have seen the reduction potential. The overall cell reaction is as given about 2.021 volts to be produced by each cell. Okay, but because we have 6 of those cells in lead acid batteries, the total amount of voltage that a lead acid battery can produce is 12 volts. Okay, so the forward reaction is the discharging process initiated by the starting of the engine. The moment you start the engine, you initiate the discharging process. Okay, and as the automobile operates, you turn on the alternator, which also helps in charging the battery. So the overall cell reaction that you have here is a reversible process. The forward reaction is the discharging process, while the backward reaction is the charging process. We will meet next week physically by God's grace to address some of the areas that you may be finding difficult to understand. Thank you very much. Do have a lovely weekend.
Okay. Yeah. Uh, show me. Show me. Yeah, let me show that. I'm not okay. Like, okay. The penny might check that. So, okay. Good morning, class. So, as a continuation of what we have been doing so far, I want to believe many of you will have done the assignment given. In furtherance of that, we'll be looking at more assignments as we round up uh, the lectures today. Uh, like I told you, please take time, look at those questions, ensure you are able to solve them. It will do you a lot of good. So last time we were looking at Bernoulli's equation, and now the equation, and how that equation is actually a consequence of the equation that we are used to. If you assume the fluid is at rest, uh, if you assume the fluid is at rest, in which case we say V is zero. This expression, that Bernoulli, you see that what we have is very near to what we know as a gauge pressure. Again, just reiterating what we have done before, if the speed of a fluid element increases as the element travels along the horizontal streamline, the pressure of the fluid must decrease, and conversely is also true. That is, in another way, where the streamlines are relatively close together, the velocity is great, and the pressure at that point is low. The pressure at the point where the velocity is much is low. We should take note of that. That is applicable to many fluids, including flow of plasma from the surface of the sun to the earth. Plasma, by way of solar wind coming from the solar surface uh, to the earth, uh, the same applies. So, flow of an ideal fluid is what we have discussed so far, and we know that an ideal fluid is incompressible, that's having a constant density, and lacks viscosity, and its flow is steady. Steady meaning that along the flow, the velocity is constant and irrotational. And of course, by definition, a streamline is a path followed by an individual fluid particle. And then a fluid, a tube of flow, is a bundle of streamlines. Okay? Fluid pressure, a fluid is a substance that can flow, it conform to the boundaries of its container because it cannot withstand shear rain stress. So we'll look at this example today. This example, sample problem. So the question is, ethanol of density 791 kilogram per meter cube flows smoothly through a horizontal pipe that tapers in cross-sectional area from an area that is 1.0, 1.20 times 10 to the minus 3 meter square to area 2, which is half of area 1. Area 2, which is half of area 1. So we want to find the pressure difference between the wide and narrow section of pipe. The pressure difference between the wide and narrow section of pipe, if it is 4120 Pascal. So we want to establish the volume flow rates of ethanol. Volume flow rate of ethanol. We decided not to show the diagram, just know that the cross section differs. Okay. So because the fluid, let's take our attendance, the first code. I don't know whether. Let's take the first code for attendance. The first code for attendance, so that we don't forget. The first code for attendance, WK 3H. WK 3H. Can you chat? Okay. Just for me to know. Okay, okay. Okay, sorry. Okay, it's all right. Sorry. So we take the first attendance, physics 103. We are on physics 103 now. WK 3H. WK 3H. Physics 103. WK 3H. We are on physics 103. Let's take note of that. That's the concluding part today. So, because the fluid flowing, that's back to our question. Because the fluid flowing through the wide section of the pipe must entirely pass through the narrow section. You know, that's what we mean by continuity equation. Okay, if you remember, because the fluid flowing through the wide section of the pipe must entirely pass through the narrow section, the volume flow rate must be the same in the two sections. I mean, we all know that. So that we can write that expression in what we have as equation 1435. So in that expression, there are two unknowns. The speed. So we cannot evaluate this from 1435. So, but if you apply Bernoulli's equation, in which case the kinetic energy density expression, that is pressure, kinetic energy density, and the potential energy density is a constant. So we apply that to the two sections of flow. And from there, we're able to establish that the speed is actually a function of the flow rate and the area. And for V2, just two of that to the area. And if we use that correctly and substitute that into the Bernoulli's equation, so that we can use that to eliminate the speed. So we'll be able to get the volume flow rate. So we are trying to look at the two equations by substitution. Okay. So we'll see that from the two equations, we just have the flow rate being something about the area across the section 1, the pressure difference, that's square root of the pressure difference, over 3 of the density. So if we're able to solve that, we'll be able to get that expression to be the volume flow rate. So let me give you 3 more questions. I gave you 3 last time. Let's take 3 more today, or even more actually. The code is three characters. WK3H. WUK3H. Let me take that again. WUK3H. WU. That's WU. Sorry, maybe there's a mistake. WU. Take that again. WUK3H. K3H. We missed the U in the first, so it should be WUK3H. So thank you. So let's have three more questions, like I said before, or even more questions actually. And like I told you, I don't know how many of you were able to solve the problem in the last one I gave you. And if there are matters arising, you let me know. So let's take the following question. Today is for interaction and to close and to bring the lecture to a close for this semester. So let's take the following question. Let's take the first one. Two streams merge. Two streams merge to form two streams merge to form a river. That is, you have a stream, you have another stream. Two of them merge to form a river. One stream has a width of 8.2 meters, depth of 3.4 meters, and current speed of 2.3 meters per second. Current speed of 2.3 meters per second. The other stream is 6.8 meters wide and 3.2 meters deep. Okay, it's all right. So just to let you know, we'll be rounding up very shortly. Maybe in the next 10 minutes or so, we'll be rounding up. But I want you to have the questions so that you can help yourself, okay? Two streams merge to form a river. One stream has a width of 8.2 meters, depth of 3.4 meters, and current speed of 2.3 meters per second. The other stream is 6.8 meters wide and 3.2 meters deep and flows at 2.2 meters per second. So these are the two streams now. That is, according to the question, the two streams actually flow, merging to form a river. You know the width, you know the length, and then you know the depth. Has a width 8.2 meters, that's the first stream, depth 3.4 meters, and current speed of 2.3 meters per second. The other stream is 6.8 meters wide, 3.2 meters deep, and flows at 2.6 meters per second. If the river has width 10.5 meters, and speed 2.9 meters per second. What is depth? What is depth? Question 2. Question 2. How much work is done by pressure? Question 2 now. Question 2. How much work is done by pressure in forcing 1.4 meter cube of water through a pipe having an internal diameter of 13 millimeters? If the difference in pressure at the two ends of the pipe is 1 atmosphere, I hope you can hear me. Then the third question now. The third question. Yeah, cancel. No, we have to. I'm on stream. I'm on the chat. But I want to see whether the chat, whether the chat is okay. The chat is okay. Okay. Whether it is everything is okay. So let's have the third question. The third question. A boat floating in fresh water. A boat floating in fresh water displaces water weighing 35.6 kilonewton. A. What is the weight of the water this boat displaces? What is the weight of the water this boat displaces when floating in salt water of density 1.1 times 10 raised to 3 kilogram per meter cube? Then the B part of the question, what is the difference between the volume of fresh water displaced? What is the difference between the volume of fresh water displaced and the volume of salt water displaced? That's the third question. Let's take the second attendance. We go ahead to take the second attendance code. We go ahead to take the second attendance code. 88 BBS 88 BBS S 88 BBS. That's the second attendance code. Please, you should be active on the chat box, so I have a feedback of what you are getting actually. I want feedback from the chat box so I can have a feel or a response, a feedback from your end. So let's take the fourth question. Let's take the fourth question. Fourth question now. Let's take the fourth question. An iron anchor. An iron anchor. I'm taking time to give you questions because physics is about questions. I hope you know. Somebody said the code should be 5 figures. Yes, it's 5 figures. 88 BBS. 88 BBS. 5 characters. That's 5 characters now. 88 BBS. 88 BBS. That's 5 characters. Then the first one is the first attendance code. Somebody is making reference to it. Somebody is making reference to the first attendance code from the chat box. Okay? So let me take that first code again. Because I can see somebody is trying. Yeah. If you check the chat box, somebody has put in, the correct code is now there. So then let me take it again for generality of the class. The code again for first attendance, for those who are here to take that. W U K 3H. That's the first attendance code. So let's take the fourth question. The questions are very important for you, just to try. And then for my own section, actually, I know computer will randomize it. So you may be lucky to pick it. And if not you, your colleague or any other person may be lucky also to pick it. So let's try. An iron anchor of density 7870 kilogram per meter cube appears 200 Newton lighter in water than in air. An iron anchor of density 7870 kilogram per meter cube appears 200 Newton lighter in water than in air. It's a good question, actually. What is the volume of the anchor? What is the volume of the anchor? That's the A part of that question. What is the volume of the anchor? Then the B part of the question. What is how much does it weigh in air? How much does it weigh in air? If you still remember OPTOS very well in your own level, you should be able to tackle this question easily. So I take it again for the last time. An iron anchor of density 7870 kilogram per meter cube appears 200 Newton lighter in water than in air. What is the volume of the anchor? That's the A part. Then the B part, how much does it weigh in air? So I've given you 4 questions today, and I gave you 3 questions last time. Okay? Making 7 questions. You must have gotten a third of the questions in this section. You must have gotten a third or more. the last one, fifth one, to make it eight, to round it up.
Sorry, sir. Please. My students have another class, so I
Uh,
cannot afford to miss their own session. Please, sir.
uh,
These are been repeatedly done. So you can just give them the last one. The question can be scanned to them.
I don't want to stand. It's a special question.
Then they can get it from through any other
Let me
means.
finish my time. It's 10 to 11. Madam?
No, you don't have that time.
Okay, don't worry.
Sorry,
Okay.
please.
A Peter 2. Sorry, madam. A Peter 2 on a high altitude aircraft. I should be rounding up. A Peter 2, I won't repeat it, on a high altitude aircraft measures a differential pressure of 200 Pascal. What is the aircraft airspeed? If the density of the air is 0.031 kilogram per meter cube. So I wish you the best of luck in the exam. I've given you like 8 questions. I wish you the best. Okay, please let's take the last code. Madam. Yes. Let me give you the last code and I'm leaving immediately because there's another class that we hold. AMS 103 we hold immediately. So let me give you the last code for attendance. Quickly take it. 7G, G for grass. 7G QN4. 7GQN4. Thank you very much. I wish you all the best in the exam. Please take time. Deliberately, I've given you those questions so that you can have them. So they won't be new to you. All the best. Thank you. It is well. Thanks very much.
Hello, good morning. AMS 103 students, if you are there, please let me see your reaction to these greetings. If you are there, please just send me I on the chat box. I'm looking out. I want to see, are you there? I am waiting. I've not seen anyone respond. AMS 103 students. I want to believe that you've not left. Yeah. While waiting for you to respond, let me quickly get in touch with your class reps on WhatsApp, and I wouldn't know what's going on. Yeah. Can you hear me at all, please? This is AMS 103, Faculty of Administration. Okay. So all your class reps, okay, someone says this is Esther, Akiola Esther Itayo. Uh, Abdul Muiz, yeah, for you it's a wrong class. Please, you can excuse us. Your class is over. So this is AM has 103, Introduction to Computing, offered by Faculty of Administration. Thank you. Wrong class. Please, you can take your leave. So I'm welcoming my students on board. Thank you. Yeah, yeah. Fixes class is over. Please let's get that settled. Just circulate the message to your class and then let them have the information that quickly please join. Let me ask you, how was your last week test? Any response to that, please? Your response to that? So what you did last week is a type of what you should expect in the examination. Meanwhile, the class of today, which is partly practical, or let me even say purely practical, will also feature in exam. So whatever we do today, please pay attention. The questions will definitely constitute part of the, the work you will be doing in exam. Okay, so I wouldn't know which one is going to take for now. We've not decided that. Okay, yes, ma'am, can hear you clearly, ma'am. Okay, thank you, ma'am. Eniola, thank you. All right, so I believe what Eniola said is true of every one of you. Okay, so once again, I like to welcome you to the class of today. So I have your reaction now concerning the test of last week. Someone was already going through it, so thank you. So today we would be looking at how we apply the use of computer to our everyday activities. You are majorly or largely students of administration, of course. there are several applications that are useful for you that you are supposed to get familiarized with. And then even those ones that are specialized that have to do with computing, engineering, and all that, coding, programming. I will not discourage you. I will actually advise that you find time during the day and learn some skills because today the emphasis and the focus with the trend globally is multidisciplinary because you don't isolate yourself and then claim to be advanced students and have nothing to do with students from other disciplines, especially from computer science and engineering. So all these have come together now, blended into one, being integrated, and you barely can find any line of demarcation because today we speak virtually the same language, only that we still try to focus on our specialization. So, with this background, okay, your name is Akira Oluwaferunmi, using your friend's phone, no Teniola. That's not a problem. Mine is that when it is time for you to take attendance, you join and then you do the needful for yourself. Okay. So with that background I've given you, um, the operating system which manages the way the system works and then uh, helps you to realize what exactly outputs you want, and then so you can use different applications to achieve your goal depending on what your expectations are. So for students in admin, some of you, let me take accounting student for example, you will need to get used to spreadsheets and then some other specialized software that are useful in accounting field for auditing, for taxation, for finance, and there are several of them. So you need to get used. But we are not going to do that because you are not all accounting students. So the department will take care of you when it gets to this, when you get to the semester that you will enroll for practical in those specialized software. Okay, so but the one that is common to every one of you, whether you are an accounting, public administration, local government, or business administration, it's word processing. So Microsoft Word. So with the use of Microsoft Word, yeah, there are several others too, like those Mac OS. So all these ones, they do similar work because your everyday work does not require much of coding like engineering. So you do some calculations, you do some preparing reports, and then set up meetings, then communicate with outside world or with the organizations within and all that, the other stakeholders, external and internal environment of the organization. And so it's actually all the departments that are the Faculty of Administration use the Microsoft software. So that's what we'll be taking for our practical today. So uh, we expect that basically as a student, you should or you will be able to uh, handle the system by boot it, that is to start the computer, to see the power button there once it is charged. So you charge it and then you switch on and then allow it to boot. So that process is very essential. So booting, and then once it is complete, then can now begin to work. Then you look for which app, which application is relevant to the activity. So in this case now, we are using Microsoft Word. So I hope we'll be able to navigate fast here because uh, this is not my own laptop. But so you stay with me here, and all of you too, you have your own laptop. I've sent to your class rep to please yeah, inform you that you would need system. So I expect you to open the system and just start it. So like I'm also trying to start and then create the system is already open up, is already being started here. So please start your own system too. Okay. So once you are done starting it, please you go to Microsoft Word and open it. You can just go to the search menu, go to the search menu, you search, and then you type Word. So if sometimes it will even pop up as some of the, uh, because it's actually used by everyone, so it might be part of the recent app that will be listed with other ones that are being commonly used by whosoever has the device. So I want to believe that you are there with me now. So here I have the word. If you can see my screen, please let me know. It is loading. So please do the same thing like I'm doing here. So you can see with what you have on the page, my own page, which you can see from your side. You may not have the same page like mine, a bit the same outlook because the recent files here will depend on what you have there. So if you have done some work, you must also see. So you can even close the files and all that. But that's not a problem. You can see new. What is important to us now? You can see this at the home page. So you see the home, you see new, you see open. So for new, you see this icon, and then if you click on it, it takes you to a new, that's a fresh page. Not the user, you are the one opening it for the first time, and whatever you want to work and keeping it will be there for you. So, and then if you look at another one, you see open. Okay, so with the open icon, you click on it, it means you want to make use of the existing file that you have locked up and then you saved, you stored them. So we've bypassed that level already in our previous discussion. Keep some files and all that, so we reference it. So today now you can now retrieve using this open. Okay, so it will open. If I click on open, it will open several ones, and then I cannot decide which one I'm searching for them. But for us, it's new. And so because it's new, new is the first on the list on this sidebar now. See, this is the new or blank document. So if I click on it now, I expect it to open and it is open. So do you have your own place? If you are there, I want to have one or two people tell me that you have already opened your own Word document, new document, please. I'm waiting for your response. No response yet. Okay, someone said yes. Okay. Yours is still loading. Please wait for it. Let it load. Let it load. So you can see my Word document here. So I have it. So I expect you to, once your own is, is it fresh? Which is the new one. So let me know if you can see my document, please. Of course, it's one minimum is married. One married. Is this yes? Thank you, sir. Okay. So I want to believe you are there. So one more minute for everyone who are still trying to load so that we won't leave you far behind. It is best you use a laptop. If you don't have, you can share with a friend. Okay. Please don't use your don't use your phone screen is not large enough to show all the bars and then the icons that will be very useful. So it's easier for you sharing with a friend if you don't have a laptop. So I think we've been able to achieve that